Hi, welcome to WahPACT. I'm Ajay and I'll be your pactor for Introduction to Polynomials. We'll be using the Wah effect, that is, what, why, when, where, who, and how to build the understanding related to polynomials. This course deals more with the zeros of polynomials and core understanding and application of division of polynomials. After completing this course, you should have a good understanding as to how to apply knowledge of polynomials in a practical way. This video can be used as a revision supplement to the NCERT book. Let's start with some facts. The assumption is that you have a good understanding about these facts at a fundamental level. Constant is a number having a fixed value and cannot be changed. The letters A, B, and C, etc. are used as constants. Variable is a quantity that may change within the context of a mathematical problem or experiment. The letters X, Y, Z, etc. are used as variables generally. Exponent is the power to which a number, symbol, or expression is to be raised. Algebraic expressions, or simple expressions as they are called, are combination of constants and variables connected by signs of algebraic operations, that is addition, subtraction, multiplication, division, and exponents also. Algebraic expressions need to have at least one variable. If not, then they are not algebraic expressions. Please treat this as a pointer. Algebraic expressions are made of terms that are independent product of factors present in the expression. The factors are constant or variables actually. For example, algebraic expression 2x cubed plus 3x has two terms, 2x cubed and 3x. Coefficient is generally the numerical constant of a term. In the above example, 2 and 3 are coefficients of terms 2x cubed and 3x respectively. Graph is a mathematical diagram that shows the variation of a variable in comparison with that of one or more other variables. The graph of y is equal to ax plus b is a straight line where a and b are constants, where a cannot be equal to 0 and x and y are variables. Let's start our journey of polynomials. So the next question is, what is a polynomial? Polynomial was formed from a Greek word poly, meaning many, combined with the Latin word nomen, meaning name. This was possibly a terminology created by the mathematicians to acknowledge something having many names. Polynomial, many names. Polynomials are algebraic expressions having whole numbers as the exponent of the variables. So 2x cubed plus 3x, 4x squared y cubed, or 5x squared y cubed z raised to the power of 4 are all polynomials. But x squared plus x raised to the power of root 2, or 4x plus x raised to the power of minus 1, or x raised to the power of 1 by 2 are not polynomials, but are algebraic expressions. If any term of an algebraic expression, the exponent value of the variable is not a whole number, the algebraic expression is not a polynomial. The coefficient need not be a whole number. It just has to be a real number. So x squared plus root 3x or 2x cubed minus 1 by 3x are polynomials. 3 is also a polynomial. All integers are polynomials and are called constant polynomials. The constant polynomial 0 is called the zero polynomial. Till now, we have understood how to identify polynomials. Let's move to the next question, which is, how are polynomials categorized? So the polynomials can be categorized based on terms. In order to create clarity, we have created a table where the first names are polynomial, number of variables, number of terms, and terms. So the categorization based on terms starts with a monomial. A polynomial that has only one term is called a monomial. For example, xy is a monomial with two variables, x and y. It has only one term, xy. The next categorization is binomial. A polynomial having only two terms is called binomial. For example, x squared plus yz cube plus x squared is a binomial with three variables. The two terms are x squared multiplied by y multiplied by z cube, and the other term is x squared. Another type of polynomial is called trinomial. And as you can guess, a polynomial having only three terms is called trinomial. For example, 2x cubed plus 3x plus 1 is a trinomial with one variable, that is x. The three terms are 2x cubed, 3x and 1. Further categorization of polynomials can be done based on the degree. But what is a degree? Degree is often confused with exponents, but they are very different. To understand degree of a polynomial, we should know how to arrive at the degree of a term. Degree of a term is the sum of exponents of the variables. For example, x squared has a degree 2, 3x squared y squared has a degree 4, and x squared y cubed z cubed has a degree 8. So in essence, we identify all the variables and their exponent values and add them. Remember, the coefficients have no significance. So let's try these for the monomial, binomial and trinomial. So for monomial, the term xy has two variables x and y. So the degree of the term becomes 2. If we look at the first term of the binomial, which is x squared y z cube, has 2 plus 1 plus 3. That is, the degree of this term is 6. If you look at the second term, which is x squared, the degree of this term becomes 2. If we look at the trinomial, the degree of the first term, 2x cubed, is 3, as it is in one variable and x is the only variable. The second term has a degree of 1. And finally, the degree of the digit 1 is 0. Then let's move forward to understand the degree of a polynomial. Degree of a polynomial is the highest value of degree in all the terms of a polynomial. For example, x cubed plus 3x plus 1 has a degree of 3, whereas x cubed plus 3xy cubed plus 1 has a degree of 4, because the second term, 3xy cubed, has a degree 4. So let's look at the monomial again. The overall degree of the polynomial becomes 2. For a binomial, we see that the degree of a polynomial becomes 6. The degree of a polynomial, which is a trinomial, becomes 3, as 3 is the largest degree of any of the terms. Polynomials in one variable of degree 1 are called linear polynomials. For example, 2x plus 1. Polynomials in one variable of degree 2 are called quadratic polynomials. For example, 2x squared plus 3. Polynomials in one variable of degree 3 are called cubic polynomials. 4x cubed plus 3x squared plus 1 is an example. A polynomial in one variable x of the degree n is an expression of the form an into x raised to the power of n plus an minus 1 into x raised to the power of n minus 1, and so on till a0 into x raised to the power of 0, which is actually equal to 1. Here, a0, a1, an minus 1 and an are all constants, and an cannot be 0. That is, the coefficient of the expression x raised to the power of n, which is an, cannot be equal to 0. If a0 is equal to a1 is equal to a2 is equal to a3 is equal to an, which is equal to 0, we get a 0 polynomial, which is denoted by 0. It is important to remember that the degree of a 0 polynomial is not defined. Independent of the number of variables, but as part of the video, further we will be focusing on polynomials with one variable. Polynomials with more than one variable are a topic for another class and time. Polynomials in one variable expressed as a value of px or qx and so on. So any polynomial can be expressed as px is equal to x cubed plus x plus 1. And so similarly qx can be expressed as 2x squared plus 3. So by now we have understood the categorization of polynomials. And next, we are going to try to understand how to calculate the value of a polynomial. The value of a polynomial is calculated by replacing the value of a variable and performing the algebraic operations such as addition, subtraction, multiplication, division, and exponent. So let's have a polynomial in one variable and see this in action. Px is equal to 4x cubed minus 2x squared minus x minus 1. Inserting x is equal to 0, we have P0 is equal to minus 1. If we insert x is equal to 1, we have P1 is equal to 4 into 1 cube minus 2 into 1 square minus 1 minus 1, which is equal to 0. If we have P of minus 1, doing the calculation, we see that P of x becomes minus 6. If for a value of x, the value of the polynomials Px becomes 0, that is P of x is equal to 0, this is how it is written, then that value of x becomes its 0. It is a very important point and I want you to take it as a pointer. So the next question is, what are zeros of a polynomial? All the values of variable for which the value of the polynomial equates to 0 are called zeros of a polynomial. Zero polynomial and zeros of a polynomial are two very different things. Take this as a pointer. In the above example, for polynomial P1 is equal to 0 implies 1 is a zero of the polynomial. It is important to note that polynomials have zeros and equations have roots. Take this also as a pointer. So if a question states P of x is equal to 0 is an equation, then all the possible values of x will be addressed as its roots. If P of x is marked as a polynomial, then the possible value of x for which P of x is equal to 0 is its zeros. A constant such as 5 has no zeros, as 5 does not depend on any variable. Every real number is a zero of a zero polynomial. All coefficients of the terms are 0. Funny as it sounds, but this is the language that is used. Many similar questions can be framed related to zeros of a polynomial. All one has to do is to insert the value of the variable in the polynomial and check if the value of the polynomial equates to 0. In the next steps, let's look at the geometrical representation of linear, quadratic, and cubic polynomials and the geometrical interpretation of zeros. So, what is geometrical representation? That would be the first question. Geometrical representation is representation of anything in visual way to get a better understanding of its shape. The objective of this course is to make you understand the geometrical representation as plotting of graphs for polynomials and the representation of zeros on the graphs. So the next question is, what is the graphical representation for the graph of a linear polynomial? For a linear polynomial, ax plus b, where a is not equal to 0, that is the example that we are taking, the graph of y is equal to ax plus b is always a straight line. This intersects the x-axis at exactly one point, that is, minus b by a, comma 0. It is important to understand and remember that the linear polynomials will always have only one zero. For example, y is equal to 3x plus 2 is a straight line passing through the point minus 1, minus 1 and 1, comma 5. The graph of y is equal to 3x plus 2 intersects the x-axis at the point minus 2 by 3, comma 0. So, minus 2 by 3 is a zero of the polynomial y is equal to 3x plus 2. Now let's see what is the graph of a quadratic polynomial. For a quadratic polynomial of the form ax squared plus bx plus c, where a is not equal to 0, obviously as if a is equal to 0, then it would become a linear polynomial. The graph of y is equal to ax squared plus bx plus c, where a is not equal to 0, is a parabola. Zeros of a quadratic polynomial ax squared plus bx plus c, where a is not equal to 0, are the x-coordinates of the points where the parabola representing y is equal to ax squared plus bx plus c intersects the x-axis. Quadratic polynomial can either have two distinct zeros or two equal zeros, that is, one zero or no zeros. Three cases can happen related to the shape of the graph of y is equal to ax squared plus bx plus c. So the case 1 is the graph cuts the x-axis at two distinct points. Here we have marked them as a and a dash. The x-coordinates of a and a dash are the two zeros of the quadratic polynomial ax squared plus bx plus c. If we look at the second case, the graph cuts x-axis exactly at one point. So the 2 points a and a dash of the case 1 coincide here to become 1 point. The x-coordinate of a is the only zero of the quadratic polynomial ax squared plus bx plus c in this case. The third case is the graph is completely above or below the x-axis. It does not cut x-axis at any point. The quadratic polynomial ax squared plus bx plus c here has no zeros in this case. Now it's time to jump towards a cubic polynomial. So what is graph of a cubic polynomial? For a cubic polynomial of the form ax cubed plus bx squared plus cx plus d, where a is not equal to 0, the graph is not a predefined shape like straight line or a parabola. It is relatively random. Cubic polynomials can have at most 3 zeros. In other words, a polynomial of degree 3 can have at most 3 zeros. For example, x cubed minus x is a cubic polynomial. As we can see, the highest degree of x is 3. So, plotting it on the graph, we see that the graph shows that the cubic polynomial is cutting the x-axis 3 times at -1, 0, and 1. This implies that these are the 3 zeros of the polynomial y is equal to x cubed minus x. X cubed, the cubic polynomial, has only 1 zeros, that is 0. Whereas x cubed minus x squared is another cubic polynomial that has 2 zeros, 0 and 1. If we plot these cubic polynomials on the graph, we see the difference. In general, a polynomial p of x of degree n, the graph of y is equal to p of x intersects the x-axis at most n points. A polynomial p of x of degree n has at most n zeros. Example can be given with graph. Let's take a deep dive where we look into the relationship of zeros and coefficients. So the next question obviously is, what is relation between zeros and coefficients? Linear polynomial is ax plus b, where a is not equal to 0. The 0 is equal to minus b by a. For a quadratic polynomial of the form ax squared plus bx plus c, where a cannot be equal to 0, let's say we have two zeros, alpha and beta. So if we write the equation, ax squared plus bx plus c is equal to k into x minus alpha in parenthesis and x minus beta in parenthesis, where k is a constant. If we expand the equation, we see that k x squared minus k into alpha plus beta in parenthesis multiplied by x plus k into alpha and beta is the equation. Comparing a is equal to k and b is equal to minus k multiplied by alpha plus beta in parenthesis and c is equal to k into alpha into beta. Here we can rightly see that alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. Please note that this is a very important pattern that will be very useful for you in the later classes too. You will have the zeros and would be asked to create the polynomials or find the values of coefficients. Treat this as a pointer. Let's take an example. Find a quadratic polynomial, the sum and product of whose zeros are -4 and 3 respectively. So let the quadratic polynomial be of the form of ax squared plus bx plus c, with alpha and beta be the zeros. Given alpha plus beta is equal to minus 4, which is equal to minus b by a, and alpha into beta is equal to 3, which is equal to c by a. Solving this, we assume that a is equal to 1, then b is equal to 4, and c is equal to 3. So one of the quadratic polynomials is x squared plus 4x plus 3. See how if we have the sum of the zeros and the product of the zeros, we can possibly arrive at a quadratic polynomial. Let's take another example. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. 6x squared minus 3 minus 7x and 3x squared minus x minus 4. This is a quadratic polynomial where we have 6x squared minus 7x minus 3. Let alpha and beta be the zeros. So 6x squared minus 7x minus 3 is equal to 2x minus 3 in parenthesis and 3x plus 1 in parenthesis. What we have done? We have rationalized the equation. Solving this, the value of 6x squared minus 7x minus 3 is 0 when 2x minus 3 is equal to 0 or 3x plus 1 is equal to 0. That is, x is equal to 3 by 2 or x is equal to minus 1 by 3 are the zeros of this quadratic polynomial. So sum of the zeros alpha plus beta is equal to 7 by 6 and the product of the zeros is equal to minus 3 by 6, which is equal to minus 1 by 2. Solving the second equation, this is also a quadratic polynomial. 3x squared minus x minus 4. So let alpha and beta be the zeros. Applying the same logic, 3x squared minus x minus 4 can be written as x plus 1 into 3x minus 4. The value of 3x squared minus x minus 4 is 0 when x plus 1 is equal to 0 or 3x minus 4 is equal to 0. That is, x is equal to minus 1 or x is equal to 4 by 3 are the two zeros of the quadratic polynomial. For sum of the zeros alpha and beta, we have 1 by 3 and the product of the zeros is equal to minus 4 by 3. So let's continue with the relationship between zeros and coefficients for cubic polynomials. For cubic polynomials of the form of ax cubed plus bx squared plus cx plus d, where a is not equal to 0, let's say we have three zeros, alpha, beta and gamma. Alpha plus beta plus gamma is equal to minus b by a. Alpha into beta plus beta into gamma plus gamma into alpha is equal to c by a. Alpha into beta into gamma is equal to minus d by a. Proof of the same is actually something for an advanced class. You would have to memorize this for now. And generally, this is not asked in the exams. But again, it's good to know. Let's take an example. Verify that 1, 2 and 3 are the zeros of the cubic polynomial x cubed minus 6x squared plus 11x minus 6. And also verify the relationship between the zeros and the coefficients. The solution is comparing the given polynomial to ax cubed plus bx squared plus cx plus d, where a cannot be equal to 0. We have a is equal to 1, b is equal to minus 6, c is equal to 11 and d is equal to minus 6 again. Here for p of 1, which is equal to 1 minus 6 plus 11 minus 6, which is equal to 0. Again, p of 2 is equal to 8 minus 24 plus 22 minus 6, which again arrives at to be 0. P of 3, which is equal to 27 minus 54 plus 33 minus 6, is also 0. So we have verified that 1, 2 and 3 are the zeros of the cubic polynomial. So the values can be taken as alpha is equal to 1, beta is equal to 2 and gamma is equal to 3. Now, if we try to verify alpha plus beta plus gamma is equal to 1 plus 2 plus 3, which is equal to 6, which is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to 2 plus 6 plus 3, which is equal to 11, which is equal to the c by a. C is equal to 11 and a is equal to 1. And finally, alpha multiplied by beta multiplied by gamma is equal to 1 into 2 into 3, which is equal to 6, which is equal to minus d by a, where d is equal to minus 6. Something really important that we wanted to teach is how to do the division of polynomials. Division can be thought of from a simple perspective. Dividend is equal to divisor into quotient plus remainder. This is the division algorithm. If a degree of p of x is greater than or equal to degree of g of x, we can find polynomials q of x and r of x. So if the degree of p of x is greater than the degree of g of x, that means px becomes the dividend, gx becomes the divisor, and where we can find the polynomials q of x and r of x, where q of x is the quotient and r of x is the remainder. So we have p of x is equal to g of x into q of x plus r of x. Keep dividing till either r of x is equal to 0 or degree of r of x is less than degree of g of x. So let's see how to divide polynomials. Take two polynomials, p of x, for example, is equal to 4x cubed plus 2x squared plus x, and a q of x equal to x, which is a monomial. If we divide the above polynomial p of x by q of x, we have 4x cubed plus 2x squared plus x as the dividend, x as the divisor. We found out the quotient as 4x squared plus 2x plus 1, and the remainder is 0. Let's take a relatively better example. Divide p of x, which is equal to 2x plus 3x squared plus 4x cubed minus 1, by q of x, which is equal to 1 plus x, to give the quotient and the remainder. So the dividend is equal to 2x plus 3x squared plus 4x cubed minus 1. The divisor is 1 plus x. So step 1 is to convert the dividend and the divisor into standard form from the descending order of degree. The dividend now becomes 4x cubed plus 3x squared plus 2x minus 1, and the divisor becomes x plus 1. Step 2 is divide the first term of dividend with the first term of the divisor, 4x cubed divided by x, which is equal to 4x squared. This gives us the first term of the quotient. Step 3 is multiply the divisor with the first term of the quotient. We have x plus 1 into 4x squared, which is equal to 4x cubed plus 4x squared. The next step, we subtract the result of step 3 from the dividend. That is 4x cubed plus 3x squared plus 2x minus 1 minus 4x cubed minus 4x squared is equal to minus x squared plus 2x minus 1. This becomes the remainder. So the quotient polynomial is 4x squared and the quotient is also 4x squared, but the remainder is minus x squared plus 2x minus 1. In step 5, the remainder from step 4 now becomes the new dividend. The divisor remains the same. We repeat step 2 now. X squared by x is equal to minus x. This is the next term of the quotient. The step 6, where we multiply the divisor with the second term of the quotient, subtract it from the new dividend. So x plus 1 multiplied by minus of x is equal to minus of x squared minus x. Subtracting it from the new dividend, minus x squared plus 2x minus 1 plus x squared plus x is equal to 3x minus 1. Now this becomes the remainder. Again, dividend is equal to minus x squared plus 2x minus 1. The quotient here is minus x for this step only, and then we have a remainder which is equal to 3x minus 1. Here, the quotient now becomes 4x squared minus x. Repeating step 5, the new remainder again now becomes the dividend, and with the same divisor, we get the next term as 3. The dividend here is equal to 3x minus 1. The quotient is equal to 3 for this step only. Remainder is equal to minus 4, and the final quotient that will come out is 4x squared minus x plus 3. As the remainder now does not have any variable term greater than the degree of the divisor, we have the final remainder. So finally, consolidating all, dividend is equal to 4x cubed plus 3x squared plus 2x minus 1. The divisor is equal to x plus 1. The remainder is equal to minus 4 and the quotient is equal to 4x squared minus x plus 3. Let's look at another example. Divide 3x squared minus x cubed minus 3x plus 5 by x minus 1 minus x squared and verify the division algorithm. Step 1, decreasing orders of their degrees. So we have minus x cubed plus 3x squared minus 3x plus 5, which is also the dividend. The divisor is minus x squared plus x minus 1. Now here we know by the age-old process, dividend is equal to divisor multiplied by quotient plus remainder. The step 2, so divide the first term of the dividend by first term of the divisor to get the first term of the quotient. So when we divide minus x cubed by minus x squared, we get plus x. So if we multiply the divisor with x, we get minus x cubed plus x squared minus x. Taking it further and stacking of x cubed, we get the remainder comes out to be 2x squared minus 2x plus 5. We continue the same process and balance the remaining expressions. As you can see, we are again trying to balance the expression and we finally get 3 as a remainder. Stop as the degree of the remainder 3 is less than 2 of the polynomials minus x squared plus x plus 1. So here we see that the remainder is 3. The quotient is equal to x minus 2. So divisor into quotient plus remainder is equal to dividend. Let's take an example. If two of the zeros of the polynomial 3x raised to the power of 4 plus 6x cubed minus 2x squared minus 10x minus 5 are root 5 divided by root 3 and minus root 5 divided by root 3. So find the remaining zeros. Solution. Let's assume that there are two zeros, root 5 divided by root 3 and minus root 5 divided by root 3. So x minus root 5 divided by root 3 multiplied by x plus root 5 by root 3 in brackets, which is equal to x squared minus 5 by 3 is equal to 3x squared minus 5 is a factor of the given polynomial. 3x raised to the power of 4 plus 6x cubed minus 2x squared minus 10x minus 5. Here we can see that 3x raised to the power of 4 plus 6x cubed minus 2x squared minus 10x minus 5 is our dividend. 3x squared minus 5 is our divisor. So we multiply 3x squared minus 5 with x squared, which will make it 3x raised to the power of 4. Here, after doing the first iteration, we get 6x cubed plus 3x squared minus 10x minus 5, and again we multiply the same by 2x, we get 6x cubed minus 10x. Finally, we are left with 3x squared minus 5 as the remainder. So finally, we multiply 3x squared minus 5 with plus 1 and we have the net result as 0 as our remainder. X squared plus 2x plus 1 is the quotient and is equal to x plus 1 whole square. The other zeros are minus 1. As for this value, x squared plus 2x plus 1 is equal to x plus 1 whole square, which is equal to 0. This brings us to the end of the chapter Polynomials. I hope you have understood the division of polynomials and a lot about polynomials, their categorization, as well as other things. It's time for you to try some challenges. Happy learning!